Ultramarine is a deep blue color and a pigment which was originally made by grinding lapis lazuli into a powder. The name comes from the Latin ultramarinus, literally, beyond the sea, because the pigment was imported into Europe from mines in Afghanistan by Italian traders during the 14th and 15th centuries. Ultramarine was the finest and most expensive blue used by Renaissance painters. It was often used for the robes of the Virgin Mary, and symbolized holiness and humility. It remained an extremely expensive pigment until a synthetic ultramarine was invented in 1826. Chemistry. The pigment consists primarily of a zeolite-based mineral containing small amounts of polysulfides. It occurs in nature as a proximate component of lapis lazuli containing a blue cubic mineral called lazurite. The pigment color code is P. Blue 2977007. The major component of lazurite is a complex sulfur-containing sodium silicate, which makes ultramarine the most complex of all mineral pigments. Some chloride is often present in the crystal lattice as well. The blue color of the pigment is due to the S-3 radical anion, which contains an unpaired electron. Production. The raw materials used in the manufacture are iron-free kaolin or some other kind of pure clay, which should contain its silica and alumina as nearly as possible in the proportion of silicon peroxide, aluminium oxide demanded by the formula assigned to ideal kaolin, anhydrous sodium sulfate, anhydrous sodium carbonate, powdered sulfur and powdered charcoal are relatively ash-free coal, or colophony in lumps. The preparation is typically made into steps. The first part of the process takes place at 700 to 750 C in a closed furnace so that sulfur, carbon and organic substances give reducing conditions. This yields a yellow-green product sometimes used as a pigment. In the second step, sulfur dioxide at 350 to 450 C is used to oxidize sulfide sulfur in the intermediate product 2s2 and SN-chroma4 molecules, resulting in the blue pigment. The mixture is heated in a kiln, sometimes in brick-sized amounts. The resultant solids are then ground and washed as per any other insoluble pigment manufacturing process. The chemical reaction produces large amounts of sulfur dioxide, meaning that flue gas desulfurization is an essential part of its manufacture to comply with pollution regulations. Large chimneys were used to disperse sulfur dioxide produced in the process, resulting in ultramarine tinting the surrounding ground surfaces and roof vents with a blue color. Ultramarine pour in silica is obtained by fusing a mixture of soft clay, sodium sulfate, charcoal, sodium carbonate and sulfur. The product is at first white, but soon turns green ultramarine when it is mixed with sulfur and heated. The sulfur burns, and a fine blue pigment is obtained. Ultramarine rich in silica is generally obtained by heating a mixture of pure clay, very fine white sand, sulfur and charcoal in a muffle furnace. A blue product is obtained at once, but a red tinge often results. The different ultramarines, green, blue, red and violet, are finely ground and washed with water. Synthetic ultramarine is a more vivid blue to the natural ultramarine. Since the particles in synthetic ultramarine are smaller and more uniform than natural ultramarine and therefore diffuse light more evenly, its color is unaffected by light nor by contact with oil or lime as used in painting. Hydrochloric acid immediately bleaches it with liberation of hydrogen sulfide. Even a small addition of zinc oxide to the reddish varieties especially causes a considerable diminution in the intensity of the color. Structure and classification of ultramarines. Ultramarine is the aluminosilicate zeolite with the sodalide structure. Sodalide consists of interconnected aluminosilicate cage. Some of these cages contain polysulfide SN-X groups that are the chromophore. The negative charge on these ions is balanced by Na+ ions that also occupy these cages. Blue, violet, and pink. The nature of the polysulfide dictates the color of the solid. The usual blue ultramarine is thought to contain S-2 as the chromophore. In violet ultramarine and pink ultramarine, the chromophore is proposed to be S-4 or S4. Applications: synthetic ultramarine, being very cheap, is largely used for wall painting, the printing of paper hangings and calico, etc., and also as a corrective for the yellowish tinge often present in things meant to be white, such as linen, paper, etc. Bluing or laundry blue is a suspension of synthetic ultramarine that is used for this purpose when washing white clothes. Also often found in makeup such as mascaras or eyeshadows. Large quantities are used in the manufacture of paper, and especially for producing a kind of pale blue writing paper which was popular in Britain. During World War I, the RAF painted the outer roundels with a color which was made on ultramarine blue. This became the S-108 aircraft blue. It was replaced in the 1960s by a new color made on phylocyanine blue, BS-110 roundel blue. History: the name derives from Middle Latin ultramarinus, literally beyond the sea, because it was imported from Asia by sea. In the past, it has also been known as Azurum ultramarine, Azurum transmarinum, Azuro ultramarino, Azadace, Pierre d'Azur, Lazurcine. Current terminology for ultramarine includes natural ultramarine, ultramar lapis, ultramarinect, ultramar genuino, and ultramarino verdadero. The first recorded use of ultramarine as a color name in English was in 1598. The first noted use of lapis lazuli as a pigment can be seen in the 6th and 7th century AD cave paintings in Afghanistan, Zoroastrian and Buddhist temples. Near the most famous source of the mineral, lapis lazuli has also been identified in Chinese paintings from the 10th and 11th centuries, in Indian mural paintings from the 11th, 12th, and 17th centuries, and on Anglo-Saxon and Norman illuminated manuscripts from c. 1100. Ultramarine in the Middle Ages, the Renaissance and Baroque. During the Renaissance, ultramarine was the finest and most expensive blue that could be used by painters. The 15th century artist Cennino Cennini wrote in his Painter's Handbook, "Ultramarine blue is a glorious, lovely and absolutely perfect pigment beyond all the pigments. It would not be possible to say anything about to do anything to it which would not make it more so." Natural ultramarine is the most difficult pigment to grind by hand, and for all except the highest quality of mineral, sheer grinding and washing produces only a pale grayish-blue powder. At the beginning of the 13th century, an improved method came into use, described by Cennino Cennini in the 15th century. This process consisted of mixing the ground material with melted wax, resins, and oils, wrapping the resulting mass in a cloth, and then kneading it in a dilute lye solution. The blue particles collect at the bottom of the pot while the impurities and colorless crystals remain. This process was performed at least 3 times, with each successive extraction generating a lower quality material. The final extraction, consisting largely of colorless material as well as a few blue particles, brings forth ultramarine ash, which is prized as a glaze for its pale blue transparency. The pigment was most extensively used during the 14th through 15th centuries, as its brilliance complemented the vermilion and gold of illuminated manuscripts and Italian panel paintings. It was valued chiefly on account of its brilliancy of tone and its inertness in opposition to sunlight, oil, and slaked lime. It is, however, extremely susceptible to even minute and dilute mineral acids and acid vapors. Dilute dilute hydrogen chloride HNO3 and H2SO4 rapidly destroy the blue color, producing hydrogen sulfide in the process. Acetic acid attacks the pigment at a much slower rate than mineral acids. Ultramarine was only used for frescoes when it was applied secco, because fresco's absorption rate made its use cost prohibitive. The pigment was mixed with a binding medium like egg to form a tempera and applied over dry plaster. European artists used the pigment sparingly, reserving the highest quality blues for the robes of Mary and the Christ child. As a result of the high price, artists sometimes economize by using a cheaper blue azurite for underpainting. Most likely imported to Europe through Venice, the pigment was seldom seen in German art or art from countries north of Italy. Due to a shortage of azurite in the late 16th and 17th century, the price for the already expensive ultramarine increased dramatically. In the 17th and 18th century, Johannes Vermeer made extensive use of ultramarine in his paintings. In Lady Standing at a Virginal, the young woman's dress is painted with a mixture of ultramarine and green earth, and ultramarine was also used to add shadows in the flesh tones. While it made a magnificent blue, it did have its defects. Scientific analysis by the National Gallery in London of Lady Standing at a Virginal showed that the ultramarine in the blue seat cushion in the foreground had degraded and become paler with time. It would have been a deeper blue when originally painted. The 19th century, the invention of synthetic ultramarine, the beginning of the development of ultramarine blue, artificial, was known from Goethe. In about 1787, he observed the blue deposits on the walls of lime kilns near Palermo in Italy. He was aware of the use of these glassy deposits as a substitute for lapis lazuli in decorative applications. He did not, however, mention if it was suitable to grind for a pigment. In 1814, Tasset observed the spontaneous formation of a blue compound, very similar to ultramarine, if not identical with it, in a lime kiln at St. Gobain, which caused the Société pour l'Encouragement d'Industrie to offer, in 1824, a prize for the artificial production of the precious color. Processes were devised by Jean-Baptiste Guimmet and by Christian G. Mellin, then professor of chemistry in Tübingen. While Guimmet kept his process a secret, G. Mellin published his, and thus became the originator of the artificial ultramarine industry. General terminology: ultramarine is a blue made from natural lapis lazuli, or its synthetic equivalent, which is sometimes called French ultramarine. Variants of the pigment ultramarine red, ultramarine green, ultramarine violet are known, and are based on similar chemistry and crystal structure. More generally, ultramarine blue can refer to a vivid blue. The term ultramarine green indicates a dark green. Barium chromate is sometimes referred to as ultramarine yellow. Ultramarine pigment has also been termed G. Mellin's blue, Guimmet's blue, new blue, oriental blue, and permanent blue.